Hello, welcome to my presentation video on photovoltaic presentation part 5. In this video, I'm going to talk about PV monitoring. Whatever the size and use of a PV installation, the main purpose of a monitoring system is to follow the PV produced energy, assess PV system performance, detect drifts or malfunctions, and notify about all faults immediately. In PV installations for grid export, the monitoring system provides measurement of the produced PV energy and calculation of its economic benefit on a daily and monthly basis, and performance assessment of the PV system, or in other words, detecting a decrease in the performance ratio and identifying potential causes, for example, temperature, dirt or dust accumulation on the PV panel surface, mismatch and wiring losses, inverter status and operation, etc. The monitoring architecture is based on a data logger, mostly equipped with a RS232/485 serial port to communicate with the inverters using Modbus or a proprietary protocol. Data acquisition is based on a low speed pooling rate every 10 minutes on average. Data may be stored locally in the data logger for a short period of time or pushed to an external server which stores data for years. The data logger can also be equipped with auxiliary inputs such as analog inputs to monitor temperature, irradiance sensors, digital inputs to monitor the status of an equipment, and pulse input to connect with an energy meter. Once the data are collected locally, the system sends output data and alerts as soon as they are generated to a remote monitoring system where cloud-based applications, analytics, or services can be provided in addition. In the case of cell consumption, the produced PV energy is consumed by the building loads. The PV production excess is generally injected into the grid. To understand how the energy is used and how it can be optimized, key performance indicators should be followed, such as percentage use of PV production, self-consumption ratio, self-production ratio, or trend analysis of PV production versus building consumption. The monitoring system should consolidate data from both PV production and building consumption. The monitoring system can be a building management or dedicated power management system integrating PV production monitoring. Systems for utility scale power plants from 500 kilovolt peak upwards are able to monitor the complete installation from the string input to the point of connection to the grid. These systems are based on a SCADA system which enables multi-site monitoring, DC and AC measurements, remote control of motorized equipment, smart alarming, report generation, performance indication, and other capabilities such as in-depth analysis. These systems also include other equipment to run the site more smoothly, efficiently, such as weather station, irradiance sensor, a plant controller communicating with the grid operator to adapt the production of the site to the grid variation in voltage or power factor, and specific meters such as revenue grade meters close to the point of connection. These SCADA systems can be local or remote with redundancy capabilities and high performance data processing. This type of installation is mostly served by a service contract for operations and maintenance, and in many cases with performance objectives, which can include production, performance ratio, or availability. On this slide, you can see an example of a system for remote monitoring used in utility scale power plants. We come to the end of this presentation. Thanks for watching.